The rendering section of the Unreal Engine 5.5 public roadmap, showcasing upcoming or experimental rendering features. Mega Lights. A new lighting system, focused on improving lighting quality and performance in large scenes. Designed for handling complex lighting scenarios with more precision and scalability. Hardware ray tracing. Enhancement in the support of hardware-based ray tracing for more realistic lighting, reflections, and shadows. This leverages the power of dedicated hardware, such as NVIDIA RTX or AMD cards, to deliver physically accurate rendering effects. Local exposure. This feature likely allows for more control over exposure settings at a localized level in scenes. Rather than having a global exposure setting, this can dynamically adapt to different lighting situations, improving visual fidelity. Path tracer volumetrics. Adding volumetric effects like fog, smoke, and cloud rendering to the path tracer. Path tracing simulates global illumination, and this feature enhances it by adding realistic light scattering and absorption in volumes. NFO, Spatiotemporal Denoiser. This is an experimental feature likely focused on improving denoising of ray-traced images, reducing noise while maintaining spatial and temporal fidelity, which is crucial for higher quality real-time rendering with ray tracing. Vulkan Ray Tracing. Vulkan, an open-source graphics API, is getting ray tracing support in beta. This will allow developers to use ray tracing features on platforms supporting Vulkan, expanding beyond DirectX environments. Path Tracer. Continued improvements to the built-in Path Tracer. This tool is typically used for offline rendering, creating images with high-quality lighting and reflections by simulating the behavior of light rays. Render pass improvements. Enhancements in render passes, which break down rendering into stages like color, depth, lighting, etc. These improvements could make compositing and post-processing more efficient and customizable. Mesh Texture Color Painting. This feature allows users to directly paint textures or colors onto mesh models. It's beneficial for artists looking for more precise and intuitive control over texturing. Orthographic rendering. Support for orthographic rendering, which renders scenes without perspective, parallel projection. This is useful for architectural visualization or technical drawings where scale is critical. Render parallelization. Optimizations that parallelize the rendering process, which should improve performance by taking full advantage of multi-core processors for faster rendering times. Day sequence. An experimental feature likely related to controlling lighting throughout a day-night cycle, allowing for realistic transitions of sunlight and shadows across different times of day. Bindless rendering. This advanced feature allows for more efficient rendering by removing the need for resource binding, making the rendering pipeline more flexible and capable of handling more complex scenes. First-person rendering. Experimental features for rendering from a first-person perspective. This could focus on optimizing the rendering of first-person views in games or simulations, improving the visual quality and interactivity. Local fog volume. A feature that allows for the placement of local fog volumes in a scene. This can create fog or mist that interacts with lighting and enhances atmospheric effects, adding more depth and realism. Substrate. A rendering system that likely improves surface shading, possibly giving developers more control over how materials interact with light. This could allow for more complex material rendering. Heterogeneous volumes. Adding support for rendering heterogeneous volumes, such as clouds, fog, or smoke, with different densities and behaviors. This will improve the realism of volumetric effects. These features and improvements are all geared towards advancing rendering capabilities in Unreal Engine 5.5.